Hello, and welcome to your Salinity, Temperature, and Density of Seawater lab. This lab has two parts. The first part, we are going to be learning about how sea surface salinity is different depending where you are on the globe. We're also going to learn the reasons that salinity is different and the processes that cause those differences in salinity. In part two, we're going to be doing a little bit of kitchen chemistry, and we are going to look at the effect of temperature and salinity on the density of water. Okay, so here's your list of items that you'll need to perform the experiment. And be sure to follow these steps right here to get your samples ready before you start part one. The salt needs a little bit of time to dissolve in the water, and it's best to have that happening while you are doing this part one work. Okay, so part one, surface salinity of the world's oceans. Essentially, our salinity can be changed by several processes that occur at the Earth's surface. The big ones are evaporation, precipitation, and runoff. And without giving away the answers to these first two questions, keep in mind that both of these processes, well, all of these processes, you are either adding fresh water to the ocean or you are removing fresh water to the ocean. And think about what happens to the salinity when you add and remove fresh water. So for this part one, you are going to be completing this chart, and this has three different locations, well, better described as latitudes on the globe. And so to complete this chart, you are going to be using a set of three maps that I have available for you that look like this. Okay, so this is a map of the salinity of the world's oceans, and you can see those three regions that we had on the table on the previous screen. We have the equator, which is at 0 latitude, and then on either side of the equator is the tropics, and these are at 23.5 degrees latitude. Fun fact, 23.5 is the tilt of the Earth on its axis. Finally, the last region is the polar regions, and these are those areas that are 80, 90 degrees latitude, and really you want to be looking at the north in this northern ocean where you don't have a continent, so you can really see what the salinity is at this high latitude. Okay, so as you can see at this table, you're going to fill in your salinity, but then we're going to try to figure out why these different regions have these different salinities. So we're going to use two more maps in order to figure that out. The first is a precipitation map, how much rainfall or how much snow is falling to the ocean, and the other is an evaporation map, how much of that seawater is evaporating. And so here are the maps you're going to use for that. We have a map of average annual precipitation, and we have a map of mean annual evaporation. And for this map, one thing to note is that we have data missing for these polar regions. How are we going to fill out that box in our table? Well, we can observe some trends. Is that evaporation rate getting higher or lower as we get to these higher latitudes? Also, we can imagine, what is the temperature like up at these polar regions? Do hot or cold conditions promote evaporation? Those are things to think about when you're filling out this box right here. Okay, lastly, you are going to provide an explanation for why the salinity is what it is at these different locations and based on this precipitation and evaporation data. Things to keep in mind, which is higher, precipitation or evaporation? The next part, we're going to be filling out this chart, and this isn't as explicitly explained through evaporation or precipitation. And for these two, you're going to have to look up your salinity perhaps in the textbook or some online sources, and feel free to just look up the reason for that salinity in these two different types of locations. Okay, part 2. How does salinity and temperature affect density? And this is where we are going to be doing some kitchen chemistry. First, there are some preview questions where we're going to make a hypothesis about what is going to happen. And then you are going to start the experiment. So keep in mind that by the time you reach this point, you should have your saltwater samples ready to go. Okay, this is what your setup should look like. You have your 3 samples. The first one, 0 parts per thousand salt, and that is the fresh water. Then we have our 10 parts per thousand and our 35 parts per thousand. Notice that I mixed these two with 2 different knives so I don't contaminate one from the other. And if we zoom out, you will see that I also have an extra sample here that I'm doing just for fun. But I also have my colored ice, roughly the same size, that I am going to use these tongs and carefully put these into the glass. Now, the goal here is to get that ice into the glass without disturbing the water as much as you can. That way you don't have that food coloring getting mixed up with the sample. Instead, you can see whether it sinks or stays at the top. I would recommend putting it in the fresh water last because that is a sample that you need to observe right away. There's some action right off the bat. And again, don't worry about this 50 parts per thousand sample. That's one that I'm doing for fun. Okay, so in this question 7, this is where you are going to give your observations. You are not only going to draw your observations on these 3 pictures of your cups, but you are also going to describe what is happening. The most important one to pay attention to right off the bat, again, is that freshwater sample. As soon as you drop that ice cube in, look to see where that colored meltwater is going. And you should be timing your experiment. And so you are going to pay attention to when that ice cube has completely melted in each of your samples. And then finally, when it is completely melted, you are going to again sketch and describe what you observed in the glasses. Now, this number 10 is important. When you have completed the experiment, make sure you take a picture of that finished state of your samples and upload that with your lab when you submit it, so I can see that you completed the experiment portion. And then finally, we have some follow-up questions. All right, as usual, if you have any questions, feel free to reach out to me via email or question board or on our weekly Zoom call. Thanks, and have fun with your kitchen chemistry.